Hi guys. So this is the work that this is the work I'm gonna set you. I've given you two previous videos that talk about introduction and methodology and allow you to check that work, improve that work, and tidy it up to your satisfaction. I am going to ask you to revisit the introduction and methodology as part of your work now, because really you want to have those tidied up and on the shelf as quickly as possible so they're just not hanging over you. Also, I'm going to ask you to start looking at hypothesis 1 because that's what we'll be doing now anyway. The way I'm going to do this is I'm going to lay out what hypothesis 1 should look like. And I'm going to do it in a way that's identical for everybody. So everybody in the whole class is going to be doing a very similar looking hypothesis 1. You'll see how. So first thing, write a title, which is hypothesis 1. Second, write an aim. What is the aim of this hypothesis? What this means is, what's the aim of this section of the study? So I've just written one up here. My aim is to investigate the variations in pH and how they impact the beach. Your aim could be to investigate the variations in almost anything that you have measured and how they influence the beach. Okay, so I need to make it very clear, if you're a beach person right now, you do not have to do pH. Don't just copy and complete this. This could be any variable that you've studied. To investigate variations in shell numbers and how they, across the beach. To investigate variations in soil moisture. If you're a soil person, it's the same. You're going to look at how something changes along your transect. If you're Daniel, who's looking at microclimatic changes, you're going to be, I'm going to investigate or study how one of your variables changes between the three zones you've studied. And if you're Louise, your first aim is to establish to investigate literacy rate and its role in affecting development. Okay, so this is an important bit to get right. What you want to do is you're basically saying, in fact I'm just going to score that out briefly and rewrite it here because I don't feel I've quite explained this very well enough yet. The aim basically wants to say, I aim to investigate. You could use any words you like here. Investigate, study, analyze, inquire into, you know, get a thesaurus. I aim to investigate how something varies. That's what your aim is essentially doing. I aim to study how something, now when we say something, what I mean here is one of your variables, e.g. pH, moisture percent, there's so many of them I can't think of any somehow. Soil texture, there you go, there's another one. Literacy rate, there's tons, okay? Obviously there's lots of you doing different things. So you aim to investigate how the literacy rate varies between ... Between what? Between the three study zones, between the upper and lower HDI groups that you've studied, between the three transects on the beach. Maybe you want to do this between the mobile and the stable dunes at the beach. That's another way of doing this. I aim to investigate how something varies. That's really what you just need to be pointing out here. Based upon this, you want to do a hypothesis. I'm just going to score all of this out actually, guys. Hypothesis. So your hypothesis needs to refer to the variable that you have identified in your aim. So let's say we're doing literacy rate. I hypothesize that, IHT, I hypothesize that the literacy rate, I don't know why I did that, guys, you can't do that in your study. I hypothesize that the literacy rate will have a relationship with, you finish it. What you all need to do is you need to make an aim that says, I investigate how something is varying between the different areas I've studied. You then need to write a hypothesis that includes that variable that you aim to study. I hypothesize that the literacy rate will have a relationship with. We are all going to do a hypothesis that seeks to find a relationship. So we'll have a relationship with, you just need to think of something reasonable, GDP. If you were a beach person, this could be, I hypothesize that pH will have a relationship with distance from the sea. I hypothesize that pH will have a relationship with shell count. I hypothesize that pH will have a relationship with soil moisture. I hypothesize that pH will have a relationship with, you know, it's not difficult to do. I need to stress again, you don't need to have pH, okay? There's no advantage to you for doing pH for hypothesis 1. Your hypothesis could equally be to take the soil study guys as the example this time, but the beach people should also take this into account. I hypothesize that soil moisture will vary with distance up the slope or distance along the transect. I hypothesize that soil moisture will have a relationship with soil texture. That would be a good one. Now, use a little bit of common sense. Do you really expect to find a relationship between soil moisture and I don't know, canopy cover, you know, the amount of leaves covering the transect? I mean, maybe you would, you know, maybe the leaves are intercepting the rainfall and that should have an impact on the amount of moisture in the ground. I just think that sounds like a little bit of a stretch. You probably want to go for something that's pretty solid, pretty well rehearsed in the textbook, something that you kind of know that you should expect to see a relationship from. Remember, in your introduction, paragraph 3, here's the introduction notes, in your background info section, you should have said what you expect to find. So if you've said here, I expect to see that pH will vary as we go along the transect, well, it makes sense that one of your aims refers to pH then, doesn't it? And then your hypothesis would be, well, I hypothesize that the pH is varying, something varies as it goes along the transect. I hypothesize that it's varying because it has a relationship with something else. That's the logic of what you're doing here, okay? You're taking something that you've previously mentioned in your introduction. You're saying you aim to investigate how it varies. You then need to make a hypothesis that says that thing that I've chosen, let's call it soil texture, it varies because it has a relationship with something else. So the only person I've not really referred to here is Daniel, so let's do one more. I aim to investigate how temperature varies between the 3 stratified zones within Pittigrew Park. I hypothesize the temperature varies as it has a relationship with altitude. Okay? That's what you all need to do for hypothesis 1. It's very important that you're using the term relationship. You can say correlation if you prefer. It means the same thing. Then what you're all going to do, all of you going to do, is you're going to make a scatter graph. The scatter graph might vary in size according to what your study looks like, okay? Let's imagine you're a beach person. You're going to have a transect 1, a transect 2, and a transect 3 scatter graph. Now, depends how clever you are. If you have a computer and you're using Excel, and if you don't have Excel, by the way, you can download it from Glow for free, so you should all have access to Excel. Depends how confident you are with it. You can either make 3 graphs, or you can combine all of these 3 graphs together and color code the dots that go on them. One color for transect 1, one color for transect 2, one color for transect 3. There are marks for this kind of thing. I don't want you to get too stressed about it though. The main thing is that you are using the appropriate graph for testing the hypothesis. That's really what is expected here. Okay, so you're going to put your variable that's in your aim on the onto this graph. So let's say we've got literacy, or whatever, moisture, soil moisture, and we've got soil texture. Now, soil texture is a good one to choose because soil texture is a subjective thing. You know, you judged it, but if you look at the soil texture chart that you should have a photo of, you'll see that each of the soil textures has a number value. Okay, so you use those number values on the scales. You plot the points and you click scatter graph in the Excel program and it will give you a trend line. You should do this for each of your transects. Okay, once you have drawn the graphs for each of your transects, you would then need to analyze those results. I'll get into what analysis looks like in a moment. I think the rest of the class need a little bit of help though on what they would do with their graphs. So for the beach guys, do a graph for each transect comparing 2 variables. For soil, it's pretty much the same. You're probably just going to have 2 graphs for soil. So if this is beach, that's what I want to see from the beach guys, literally on the size of the page. This is the size of the graph. This would be appropriate. For soil, most of you have got 2 transects, I believe. So you would do either a scatter graph that has 2 plot lines on it with 2 sets of dots but done in different colors, or you would do, you know, transect 1 and transect 2. Right, if you were doing temperature versus altitude, well, what you're looking for here is one scatter plot graph. This shows temperature versus altitude, and you need to work out what. So to do that, Daniel, you're going to want to make a little table that puts temperature versus altitude, and I need the temperature at each altitude as you go up. Okay. So where was the lowest altitude? What was the temperature at that site? What was the highest altitude? What was the temperature at that site? Then you would be able to plot your graph, so you'd get away with just one scatter plot graph, and for that's microclimate, and for development, again this one lays itself out quite nicely. You would want to do, and remember, don't call them this, please. That's the whole point of your study. Rich versus poor, you're going to do a scatter plot for each, and you're going to do, I don't know, GNP literacy and GNP literacy, and you're going to see that the poor countries have got a, you know, an inverse relationship, and the rich countries have got a positive relationship. Okay, so now that we've covered all those basics, how do you analyze these results? Well, in advanced higher geography, analysis is basically the word they use for describe and explain. Okay, you're going to get marks for describing these graphs, and I'll go through that first. When you're describing the graphs, you want to point out more than just this graph shows a high value and a low value. What you're trying to show is how does it relate to your hypothesis. So point out that, and I'm just going to talk here rather than write. I'll try and do some writing. This is going to have a subheading, which is analysis, and underneath it you're going to say that the graphs have relationships. Those relationships are positive or negative. Are they strongly positive? Are they weak positive? Remember, if a graph has a perfect 45-degree angle, then it is a perfect correlation and it can't be stronger. The more the line tends towards horizontal, the weaker the relationship. Indeed, if you get a scatter plot that shows a line that's something like that, then that's basically saying there's no relationship. Some analysis would include a Spearman's rank test. Let's test the strength of the relationship. So, how strong is it according to Spearman's rank? You're all going to use Spearman's rank. I don't care who you are, you're all doing hypothesis 1 with Spearman's rank. Some of you might be wrinkling your brow there and saying, hang on, I want to do pH versus distance, and isn't that parametric, and shouldn't I use Pearson's? You are technically correct, and if you feel confident enough in making that evaluation for yourself, then you should go ahead and use Pearson's. The overall structure of this hypothesis will not be affected. That said, though, assuming that you're studying something which is non-parametric, i.e. GNP versus literacy, i.e. temperature versus altitude, soil moisture versus texture, pH. If you did do pH versus distance, that is parametric because it's got distance in it. And technically speaking, Pearson's is the better one to use. However, that does not make Spearman's invalid as a statistical technique. You can still use Spearman's. Spearman's is easier to use than Pearson's, that's why I'm pushing Spearman's, but I'm just alerting you all to that. So, Spearman's rank test, or if you are certain of its use, use a Pearson's test to test how strong the relationships that you've already described are. So we're analysing, what do these lines show us? They show a positive correlation between GNP and literacy, and in the poor countries we see a negative correlation between GNP and literacy. The negative correlation appears to be stronger than the positive correlation that we see in graph 1. Say something like that. The Spearman's rank test that I have conducted shows that there is indeed a relationship between GNP and literacy, and a relationship between GNP and literacy in the poor countries. Alternatively, your Spearman's rank test will show that I cannot be statistically certain at 95% accuracy that there is a relationship between literacy and GNP. So, what do we do then? So you're all going to do a paragraph 1, that tells me what do you see in these graphs. There is actually a third element to that. You're going to tell me if the graph is positive or negative. You're going to tell me, based upon your observation of the graph, if you believe this to be a strong or weak correlation. You can also point out anomalies, by the way. That means extreme values. So for example, if I was to draw this one, we've got data points that are doing this, and you can see the trend line. Well, this one and this one are anomalous. They're miles away from the trend line. So you could point out there are anomalies at GNP X and literacy Y, and you could identify which country that is. Or you could with respect to everyone else. You could identify which, Daniel, here's the anomaly, you could identify which site that is. Where is that on your on input in Grief Park? Or if you are a soil person, where on Transect 2 is that anomaly? At what height and at what site number, etc. was that? Are these anomalies that you're finding in the upper half of the slope? Are these anomalies you're finding in the mobile or the stable dunes? Okay, so look out for anomalies. If you see them, point them out and see if you can spot some kind of pattern to them. You know, are the anomalies all above the trend line? Are they all below the trend line? This is the trend line. Are they all in the mobile dunes, all in the stable dunes, all in the upper slope? Are they evenly spread on either side of the mobile and stable dunes? Are they evenly spread between the poor and the rich countries? But anomalies are quite a quick route to scoring a quick analytical mark, because you are analysing the graphs that are in front of you. You are looking at them, showing your understanding of them. Another thing you can point out with the relationships is, again, if I work on this cartoon here, let's say Louise has made a graph and it looks like this. So she's pointed out that there are some anomalies, well done, and those anomalies exist here and here, and she's able to tell us which countries they are because she can look those values up in her data table. If you're anyone else, you've pointed out that the anomalies are here and here, and you're able to tell me which transect they're on and where they are in the transect, and you know, you've analysed that. Is there a significance to where these anomalies are found? But also, look here, there seems to be a concentration of data at one end of the graph. So even though there are, of course, some very poor countries with very high literacy, it seems to be that the data points are concentrated down here. And by spotting these kinds of concentrations, this is also an analysis. So you can say, if we flick to somebody else's graph here, where we've got soil texture and soil moisture, and we've got a concentration of dots up here and fewer dots elsewhere, we can say that clearly there is a positive correlation between moisture and soil texture. The moister it gets, the more soil-like the soil becomes. There are some anomalies here, and those anomalies stand out to me because they are both in the upper half of my soil catena. They're both in the stable dunes, whatever. And it's notable that 2/3 of the data points collected occurred in the upper half of the soil moisture range, and this must be significant. So there's quite a lot you can spot on a scatter graph. You can spot concentrations of dots that suggest that there must be something important happening in certain areas of the data range. You can spot anomalies, and of course you can spot the overall trend, the overall correlation, the overall relationship. You can then, and you should all, use a statistical test. I've already spoken about this. Spearman's rank is the easiest, though you may use Pearson's if you feel it is appropriate to your study. Remember, that only works for parametric tests of 30 data points or more. Okay, so if you're the beach person, Spearman's is best because each of your transects has 11 sample sites on it, not 30. So Spearman's rank is going to work best for you there. You could, if you wished, you could put a asterisk on this, and you could say this asterisk, or an asterisk, or a footnote, whatever, and that footnote is going to go to the bottom of the page and say refer to methodology. And you could put a special section at the bottom of your methodology which is called like other notes, because here you could refer the person who's reading this back and say, I recognize that Spearman's rank is not the ideal test to use. it would be better to use Pearson's because it's parametric. However, I didn't have a data set large enough to support that. Now that's really good advanced higher work if you can do that. Okay, moving on from complexity such as that though. So you've described what you've seen in the graph. We've got anomalies, we've got concentrations. That's the concentrations I was talking about. Anomalies, as I've mentioned, positive or negative, what does the line show, and how strong is that? Does it look like a strong relationship? You've then done a statistical test. Okay, let's say your Spearman's rank test definitely proves there's a relationship. I'll be honest with you guys, most of your data is not going to do that. Live field data never does what the textbook says it should do. But there will be some of you who do get a Spearman's rank test. That proves with 95 or even better, 99% certainty that there is indeed a correlation. Okay, so what do you do next? Well, what you want to do is you want to find further ways to analyze this. This involves drawing further graphs. Let's say that you have done GNP versus literacy. Your next step is to draw, not that big. Sorry, I'm trying to keep this all to be roughly the amount of space you'd use on the page. You're going to draw a literacy graph, and that would be a line graph. You're going to draw a GNP graph, and that would be a line graph. And this will allow you then to analyze further the relationships that you're finding. So as you can see, GNP is, it's hard for me to make this up without having real data to work with. Bear with me, guys. If you're doing moisture versus soil texture, I want you to do a line graph of that. Moisture, texture. Okay, whatever it is that you're doing, really, you want to have some kind of graph that shows the individual variables that you're comparing in a suitable way. Okay, if you want to check with me what the most suitable graph to use is before you draw them, that's absolutely fine. Just drop me a line because it might vary. So for example, some of you might be doing vegetation percentage versus pH. Well, pH is definitely a line graph, whereas vegetation percentage is best done as a kite graph. So this is an area where you might just want to check in with me and say, can I just check I'm doing the right thing here? That said, if you're pretty comfortable with what you're doing, just bash on and go ahead and do it. In the end of the day, if you do make a mistake, it's just a graph that you've drawn. You know, it's not the end of the world. And remember, when you do this in draft form, it doesn't need to be perfectly colored. It doesn't have to be, you know, the graphs can be done a little bit messy as long as I understand what I'm looking at and you understand what you're looking at and they're neat enough for you to be able to analyze. Regardless, what you should have done is you should have analyzed the scatter graphs that you've made. You should have then done a Spearman's rank test. That will either back up or not back up your hypothesis. You should then draw two graphs that show the individual variables that you have been analyzing. And you should then go on to make some conclusions. So we're looking for a how does the stats test how does the stats test tell us what does the stats test tell us about the hypothesis? Okay, so are you 99% certain that there is a relationship, or are you less than 95% there's a relationship, and therefore you cannot prove that there is a relationship between pH and moisture? Okay, It's really important you include that statement. Let's say that your stats tests don't back you up. That's more likely, that you've not got a relationship between something that you really expect there to be a relationship between. Well, what you say is, this is not as I expected. Referring to graphs 3 and 4, these are 3 and 4, by the way. These would be graphs 1 and 2. Referring to graphs 3 and 4, we can see that. And from these graphs, what you should find is that there will be anomalies. There will be, if GNP and literacy aren't showing a relationship, if the Spearman's rank is not backing you up, then you should find that there's some kind of deviation in the line. There's something happening in the line that explains why Spearman's rank can't back you up. So that's what you need to do. It's difficult for me to kind of walk you through this because, of course, it's all based upon the data that you collect. But if you find that you don't get a result, these line graphs should help you see why that is, because the line should do something funny or do something unusual that has affected and skewed the data. So referring to graphs 3 and 4, we can see that there are anomalies that explain how the relationship cannot exist. And then if you want bonus marks, what you can do is you can try and explain why those anomalies exist. Now, the anomalies can be explained by, and this is where you have to be a bit of a geographer, to be honest. You have got a land use map that you could refer to. Will your land use map allow you to explain why the moisture content was unusually low at a certain area? Will your geology map allow you to explain possibly why the vegetation levels were unexpectedly high at a certain area? Are there other data sets that you have that would allow you to explain why the moisture level, the pH level, the temperature level was particularly not fitting with your expectations? If you refer to another data set in that way, then you must include a suitable graph of that data set. So I appreciate this is getting a bit long-winded, guys, but I am basically teaching you new content here. So I'm just going to pause there very briefly and just go back through what we've covered. This will be work I'm going to expect you to actually do for yourself, okay? Hypothesis 1 is the title. You need to have an aim, which is to investigate how something, one of your variables, varies between the areas you've studied. After that, you write hypothesis. I hypothesized that the variable you've chosen will have a relationship with another variable. What you're basically saying is that the variable you have chosen as your aim varies because it has a relationship with something else. You then need to do scatter graphs. According to whether you're beach, soil, microclimate, or development, your scatter graphs will, of course, some of you will do 3 of them, some of you will do 2, some of you will do 1. But the point is you need to have scatter graphs. You should use Excel, the software program, to make those scatter graphs, as you, being a puny human, will not be able to accurately draw the lines of best fit. From there, you will then begin to analyze. To analyze, what you do is you first of all focus on the graphs themselves. What relationships do they show? Are they positive or negative? Are they strongly positive, or do they show potentially weak relationships? There's nothing wrong with it if they do show weak relationships, by the way. Your study is not worse for that. You score marks by pointing them out either way. Are there anomalies that you should be pointing to? Extreme values? If there are, what are those extreme values, and can you, for real marks here, can you link that to the actual geography on the ground? Where were those extreme values? I talked about that at length earlier. And are there concentrations of data in the mobile dunes, or in the upper slope, or in the upper altitudinal zone of the park? Once you've described these two graphs, you should then do a stats test. How strong is this relationship that you've spotted? Your stats test needs to end with a concluding statement that says, based on the Spearman's rank test that I've done at 10 degrees of freedom, I can say that I am 93% certain of a relationship, and this falls below the threshold for statistical certainty, and therefore I must accept my null hypothesis. I should have pointed out earlier, guys. I apologize. You must include a null hypothesis as well underneath your hypothesis. So, you've done your Spearman's rank test and you've written a concluding statement. What does the stats test tell us about the hypothesis? Well, your stats test tells you are less than 95% certain, therefore you must reject your hypothesis and accept the null hypothesis that there is no relationship between moisture and pH or whatever. It's really important that you write that because you'll get marks for it. For further analysis, you go on and you say, well, this isn't as I expected. Let's see if we can figure out why. That's when you need to do some more graphs. Doing a graph of each of the things that occurred on your scatter plot is the way to do it. You can check with me if you're not sure that you're drawing the right graphs. For most things, a line graph will be appropriate. And what you want to do is refer to the two graphs and see what anomalies explain why Spearman's rank wouldn't give you a plus 95% relationship. And if you can, you should go on to say these anomalies can also be explained by either the land use map that you've previously annotated, other maps that you've gathered of the area, or other data sets. But if you do refer to another data set that explains why there's such a an odd data set for literacy rate or for whatever it is that's in your study, you must draw a graph of that to demonstrate it to the examiner. Okay, what if though your concluding statement here says my Spearman's rank test shows that above 95% certainty that there is a relationship, therefore I can accept my hypothesis and reject my null hypothesis. There is a relationship between moisture and pH. Well, it's exactly the same again. You say, this is as I expected, and referring to graphs 3 and 4, we can see these patterns support this. The two graphs rise in value equally at a similar in a similar trend. You can spot similarities between the graphs rather than differences between the graphs. And instead of trying to use your land use map and your other maps and your other data sets to explain why something isn't happening, you should try to use it to explain why something is happening. In terms of word count, really, these sections here, this is where all the marks are scored. You genuinely could be done if you were super to the point and on the ball and keeping everything focused on using data-led explanations. You could be done in 100 to 150 words. Genuinely, you could. Most of you are probably going to trade in around about 300 words. That's my experience. And that's because you'll waffle and you'll try to make you'll be kind of groping in the dark a little bit to find the marks. Well, that's understandable, guys, because this is advanced higher and it is challenging. But this section here is the bit to really focus on. So let me just run through it one more time. Once you've drawn the scatter graphs, and you have done a stats test. Tell me what the stats test shows about the scatter graphs. And tell me what your basic description of those scatter graphs is, as I've taken you through now. I've taken you through that twice now. You will be scoring marks just for doing those things. Keep your English level high, but also try to come to the point quickly. You must conclude with a statement that says, you know, I'm 95% certain that there is a relationship between, and that therefore I can accept my hypothesis and reject my null hypothesis, or the other way around if your stat test doesn't support it. Say whether it's expected or if it's not as you expected. Refer to graphs of each data set, and within those graphs you'll either see anomalies and funny bulges in the line that you've drawn, or variations in the bars that you've drawn if it happens to be a bar graph, or variations in the kite shape that explain why Spearman's rank has come back with a result that says it can't be certain there's a relationship. There must be something. If there's no relationship, there must be something that is throwing the data out. There must be something to make Spearman's rank uncertain. And what you're looking for is big differences between your two variables. If you can, you should then look for other ways that your anomalies can be explained. Why are these funny deviations from what we expected to happen happening? And you can refer to almost any geographical source. But the best ones and the easiest ones are the ones that you have to hand, and those are your land use map that you've already done. It's in your introduction. Those are your geology map, perhaps, if you've done one. Those are your other data sets. You may find there are other data sets that show why moisture level was different. An example of how you would do that would be, let's say you've done moisture and you found that your moisture level has a big downward dip in it, and that probably explains why the moisture level and the soil texture level doesn't have a corresponding dip. Therefore, that probably explains why there's not a relationship that Spearman's could prove. Well, if you were then to look up your vegetation amounts, and your vegetation amount shows that there was actually a really high amount of vegetation at the same point, then that would explain why there's a big dip in the moisture content, wouldn't it? Because the amount of vegetation would increase the interception and affect the moisture level. So that's the kind of analytical thing we're looking for. That's the reason I've left it till last. If you can look at the other data and say the reason that there's an anomaly here is because in the rest of my data I can see that perhaps this is a factor influencing things, and therefore that's why Spearman's isn't giving me a positive result. If Spearman's does back you up, then you just do the opposite. You refer to the graphs and you say why things are happening. So the fact that the two lines on the line graphs are following identical trends. They do have anomalies, but their anomalies match. You know, they've got little kinks and bulges, but they broadly correlate with each other. And you can even do the same process with with using your other data. Those anomalies and bulges, they may exist because of an increased amount of vegetation at that point on the transect line, but the fact that they occur at the same point and that they are those anomalies are reflected in both of the graphs that I've drawn means that there is still a relationship between moisture and texture, or pH and vegetation amount, or whatever it is that you're sampling. If you keep this quite to the point and data driven, whatever you're saying, you want to be relating it to something factual. What we're not looking for here is long rambling explanations of why soil moisture varies down a slope. That's not the point. what we want you to be doing here is to saying, I can see from my soil moisture graph that there is a relationship. I have looked at both the variables involved in that, moisture and texture, and I can see that although there are anomalies, those anomalies occur at the same locations, and therefore that supports that there is a relationship. Those anomalies could be explained by the fact that looking at my other data, there's something else happening at this point on the transect line, and there's a footpath nearby, or there's a increased vegetation cover, and that might be influencing and affecting that anomaly. And I've done my Spearman's rank test, and it proves at 95% certainty that there's a relationship. We're looking for about 3 or 4 analytical marks. 1 analytical mark is scored for the stats. Okay? For doing the stats, for the process of doing the calculation. You'll get 1 for the conclusion, just like you would in the exam. You'll get 1 from the conclusion of your stats. Does it prove or disprove your null hypothesis? You'll get 1 for, or you'll get +1 for each valid analytical statement there after that point. So referring to these graphs and seeing where the similarities or the differences lie, and linking those to your understanding of why your hypothesis was proven or disproven, that's a mark. For finding any other ways that you can explain the similarities or dissimilarities between the graphs and using that to explain why your hypothesis was proven or disproven is a mark. Obviously, these last 2 sections are harder, but that's why it's called advanced higher. That's where the difficulty lies. And yeah, I would conclude by saying, do not be downhearted if when you do your Spearman's rank test it goes, no, you don't have a relationship. I need to make this very clear because some people get this wrong every single time. Some of you will think, oh, I've messed up, my results are all wrong, my study's terrible, Spearman's rank has not said I have a relationship. If you are thinking that, you have fundamentally misunderstood everything I've been teaching you. Spearman's rank proves as a fact if there is or there isn't a relationship. So if your Spearman's rank test comes back and says you're nowhere near certain of a relationship, there's definitely no relationship here, then that's good. That's a good thing. What your tests show, what your data shows, is that on the slope you analysed, on the beach you went to, on the data you sampled from the atlas or that you sampled in the park, the data you actually gathered, it does not support what the textbook says should happen. It's not your fault, it's the data's fault. And you can, I believe, actually it's easier to explain why things aren't happening than why they are happening, in actual fact. It's easier to spot deviations and anomalies in the data than it is similarities. So in total, your hypothesis is going to stretch probably, here's your aim, there's your hypothesis, here's your 3 graphs. That's probably about a page or half a page. Depends how big you make these 3 graphs, but they could just fit like that. So let's call that half a page. Then you've got your analysis of your scatter graphs. Let's call that, that's definitely all fitting on page 1, those 2 sections. Then you've got your 2 graphs that show your 2 variables. And of course, if you are going to refer to another set of data, you need to include a graph of that data. So let's allow for space for 3, maybe even 4 graphs on this page, but definitely a minimum of 2. And then there's the analysis that you would make, your stats conclusion, and then any further analytical statements. So in summary, the whole hypothesis for hypothesis 1 will fit on, I don't know how well you can see this now, 2 sheets of paper. Title, aim, hypothesis, null hypothesis, your scatter graphs, a description of what the scatter graphs show, a stats test. You don't need to show the working for the stats test, but it's a good idea to show like the equation, show the degrees of freedom that you did the stats test to, and show the result and stuff. Make a bit of a fancy job of it. You know, you don't just want to include in a sentence, I did Spearman's and it proved me wrong. Like, show that you've done it. Show off that skill, because you're getting marks for that skill. And then you need to do these analytical paragraphs. Now, after inserting those graphs, that's all going to fit on 2 sides of paper for me. So that's hypothesis 1, okay? Now, I appreciate you've got prelims coming up, but, or central assessments, the issue is that, and I'll be completely frank with you guys, I don't want to worry you, but let's just be honest with each other. If we are coming back to school after 3 weeks of isolation and then we run the central assessments, which I'm making that up, I need to make that clear, I've not seen that in writing anyway, in any shape or form, I'm just hypothesizing, then those central assessments are going to take a fortnight to run. That puts us, even if we come back to school in 2 weeks, that puts us at the February break by the time we're getting back to classwork. So, and of course, if you've been watching recent headlines, it's not impossible that the lockdowns could be continued. So I think we need to be alive to all of this. So I will be setting you a deadline for this work on your hypothesis, all right? With that in mind, it's also really, really important that those of you who have not tidied up and finished off your issues essays, get that done. That is a priority. That is hanging over some of your heads now. And that's going to become an unmanageable workload as you move forward. So I will be setting a deadline for hypothesis 1. And I have given you 2 previous videos to help you address the corrections that you might need to make in the introduction and the methodology. Okay. I also have made myself available on Thursday afternoon for a revision class, and I suppose you could ask me some questions there if you wanted to. I hope that all helped, guys.